We're going to look at another set of parametric equations, and we're going to graph it. This time it's a circle. Normally we have regular equations for a circle. They're not functions, but they're relations. The Cartesian equations, that just means using x and y only, not any parameter. But this is the parametric version of that. So we're going to just go through and graph this by hand. And in class I'll show you how to do it on the calculator. But right now there's a couple new terms, which are initial and terminal points. That just means the first point that you plot when you plug in t being 0 to both of these. That's the x and y. And then the terminal point is when you plug in 2 pi. So I'm going to make a table of values and start chugging away. The first thing I'm going to do is just write out my t values. I'm going from 0 to 2 pi, so I'll just do all of the increments on the unit circle. So 0, I don't remember actually. Shoot, maybe I won't do all of them. Maybe I'll do the main ones. Pi over 4. And then, so that's the middle. If we're looking at the unit circle, that would be there. So I'll go 0, there, 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 there. Those are the ones that I'm going to be doing. So I would have pi over 4, and then pi over 2, and so on, all the way around. Okay, so I've written down all of those increments, and then t values, and then I'll plug stuff in. So cosine of 0, well, maybe I'll draw the unit circle again. Cosine of 0, that's the x coordinate here, that would be 1. So 1 times 2 is 2. And then for the y, sine of 0 is 0. And then we have pi over 4, that would be, what, root 2 over 2 times 2, so that's just the square root of 2, which is approximately like 1.4-ish, just so we have an idea. And then same thing for sine. And I'm just going to fill in the rest of them. I'll pause the video and fill in the rest. And there I go. I have all those values. And it kind of repeats. There's a pattern here. But let's graph it. Let's see what happens when we graph it. Hold on. I have no coordinates that are bigger than 2, so I just went out to 2. This is my x. This is my y. And I'm going to start graphing. So I'll do this in red. 2 comma 0. And then that's like 1.4-ish, so somewhere over here, and then 1.4, oh, no, 1.4, somewhere over here. And then same with this 1.4-ish right there. So what I do with parametric equations, there is a direction, actually. That's something that's new. For regular graphs, you don't really have a direction, but we have the parameter, and it starts at some place, and it goes and it ends at some place. So there is a starting and an end. This is the initial point, because that's the first point that we get when we plug in the very first value of the parameter t. So this is the initial point, IP, and then we have, well, the terminal point would be actually the same. TP, not toilet paper. And we have the direction, and I can already see that it's, I'm going to connect those. It's a circle, we already know that, but the direction is the positive radian direction, which is counterclockwise. So I'm indicating the direction with an arrow. And then I have 0, 2, so then it continues. I have, I'm just going to do the rest kind of quickly. And it goes around, and around, and around. And there you go. That's it. There's your circle, and it's going. What did it say? Find the Cartesian equation for the curve. I think I'll do that right now. This actually happens a lot in polar coordinates. And we'll get to that eventually, but I'm going to use these facts. I think we dealt with this in trig pre-calc. I'm pretty sure we did. You can have your x coordinate is going to be, actually, let's hold on for a second. to get the Cartesian equation, meaning just involving x's and y's, we have to do some kind of trickery. It's not really trickery. We just have to realize that the cosine, we have cosine and sine. So one fact that we hopefully remember is that if we have sine squared, I'm going to say t, right? Yeah. Sine squared t plus cosine squared t, that equals 1. So I'm going to use that fact, and I'm going to write, I have a definition for x, I have a definition for y. I kind of want to have sine squared and cosine squared. That way I can rewrite this without any t's. That's what it means to find a Cartesian equation. Write it without using that parameter. You're just going to have x's and y's. How do we do that? Well, if I can get something like this, I can replace those functions, those trig functions, with just the number 1, which doesn't involve t at all. So let's do that. I'll just take this and square it. So I get, well, if I square this side, I'll square this side. So I'll have x squared, and that's the same thing as 4 cosine squared t. And then also, y squared is 4 sine squared t. Now I'm going to try and write an equation. I remember I want to use this fact. I want to use this. Maybe I'll underline it or put a box around it. I want to use that. So I need to have some kind of addition somewhere. So I'll take 4 sine squared t plus 4 cosine squared t. And effectively, this is just y squared plus x squared. Y squared plus x squared. So now I have an equation, but I want to eliminate the t because I want just a Cartesian equation. So what do I do? Well, I can see, or I see that I can factor out a 4, so I'll do that. Sine squared t plus 4, nope, not 4, I factored it out. Cosine squared t. Now I have something that I can work with. This becomes 1 by using that fact over here. And then I have 4 times 1 equals, I'm going to switch those around, x squared plus y squared. So really, I have an equation of a circle. X squared plus y squared equals 4. There we go. So there we go. I think we did everything that it said. The initial point is when t equals 0, and it's 2, 0. And the terminal point is when t equals 2 pi, it's also 2, 0. And that's it for this video.